physics behind auto racing. This video will discuss three important aspects of automobile racing: using friction to generate force, using the law of inertia to balance speed against fuel efficiency, and using the Doppler effect to explain sound heard as an automobile passes by. Let's start with generating a forward force. Almost everyone knows that cars generate power by burning fuel in their engines. Then they use this power to turn the tires. But how does turning the tires make the car move forwards? Forward force is a requirement for any type of racing, so it is very important that we understand how the automobile generates this forward force, because without it, there would be no race. Believe it or not, the car actually uses friction. Yes, the force which opposes movement is ironically used to get the car moving. Let's look at the spinning wheel. It is spinning counterclockwise, but where it is touching the ground, the wheel is moving towards us and the bike is moving forwards away from us. As the tire turns, it applies a force upon the ground in the direction it is turning in, which is towards us in this case. Due to Newton's third law of motion, the ground applies the same force upon the wheel in the opposite direction, which is away from us in this case. Acceleration equals force divided by mass, and since the Earth is very heavy and massive, it barely accelerates and moves. The automobile, however, is relatively light as compared to the Earth and not very massive. Thus, the automobile experiences a lot more acceleration and movement. As a result, increasing the maximum amount of friction will increase the maximum acceleration. So usually it is better for tires not to slide along the road, so that they use static friction instead of kinetic friction, since maximum static friction is higher than maximum kinetic friction. Since friction is the driving force or forward force of the automobile, the only thing trying to stop the automobile's movement is the force of air resistance, or drag force, as it is more commonly known. This brings us to the second aspect: balancing speed and fuel efficiency using the law of inertia. In a race, the objective is to finish the race with the lowest amount of time. This can be achieved by having the highest speed or the smallest distance, or both, since time equals distance divided by speed. Since many races are done inside of a restricted racetrack with a set amount of laps, the distance from start to finish cannot be reduced very much, as there are not many shortcuts. This leaves drivers with one strategy: obtaining the highest average speed. Unfortunately, in many races in NASCAR and Formula 1 and other similar cups, there are so many laps inside every race that drivers must make frequent pit stops to get more fuel and change tires. This costs racers precious time, as they must slow down, stop, and wait a few seconds, and then resume the race once everything is done. This reduces the average speed by quite a bit. The number of pit stops a racer must take is dependent on how fast they run out of fuel and how fast they wear out the tires. These two things are dependent on the speed of the vehicle. The faster the vehicle, the more the fuel consumption, and the faster the wear and tear on the tires. The higher fuel consumption is due to the fact that at higher speeds, air resistance increases, and so does the force it exerts. To maintain a constant speed, the automobile must increase the forward force to match and cancel the drag force and achieve a net force of 0. The higher wear and tear on the tire is due to the fact that turning in an automobile, the tires slide across the ground. This sliding mirrors of the tires, and at higher speeds, more surface area of the tire slides around in every turn. Lastly, let's talk about the sound heard as an automobile passes by. The sound emitted by the vehicle doesn't actually change, but the sound heard by a person does due to the Doppler effect and how sound amplitude changes across distances. This effect changes the frequency of the sound heard based upon the emitting object's relative velocity to the hearer. If the emitting object is traveling towards the hearer, the frequency heard will be higher, and if the object is traveling away, the frequency heard will be lower. The hearer of the sound isn't moving. The frequency heard can be calculated by multiplying the emitted frequency by the quotient of the velocity of sound divided by the velocity of sound plus the velocity of the object which emitted the sound. The velocity of the sound is equal to 332 meters per second plus 0.6 times the temperature in Celsius. The other reason why the sound is created is due to the fact that sound amplitude is inversely proportional to distance from the source. This means that as the car passes by, the sound heard is of lower amplitude and higher frequency as compared to the sound emitted. As the car gets closer towards the hearer, the amplitude rises. Once the automobile passes the hearer, the frequency drops, and the amplitude starts decreasing again. Although automobile racing can be played without the sound, it is still very important to the sport. This is because the sound excites many viewers, fans, and other people, which leads to more interest, which in turn leads to more viewers and sponsorships. This all contributes to generating sources of income for the racers and the organizers.